Oh, recording and such, right? Yeah.
Recording at the same time.
Appears.
Is this Dr. Bhutyani's screen that we're seeing?
Am I seen? My video is seen?
Yes. Can you please get stop sharing so I can
Stop the screen share. Yeah.
Stop the screen share.
Okay, that's a screenshot.
Yes, sir.
Okay.
So it's
My
recording.
video
This
is not seen.
Facebook Live. And
It's coming.
okay. And I'm going to share the screen also. So you should be able to share this, see the screen.
Ok. Já, ég er ekki með headset þannig að þurfti nú að þetta er eitthvað sköldur heyrist ekki.
So it's already started. We are getting some people. Let's give 1 or 2 minutes for people to join.
Are you having to admit them one by one?
No, they can
That's
join.
really-
Yeah.
Yes.
But that would have been very disruptive. So let us start. Good morning, good afternoon, and good evening, depending on where you are. Thank you for joining us for the webinar on a very important topic, restoration of Greenland and Himalayan. My name is Soumitra Das. I'm the president of Healthy Climate Initiative. I have the honor to introduce the agenda and the speaker for. Before I begin, I want to say a few words about the genesis of. As you all know, Greenland and Himalayan glaciers are melting at an alarming rate. Since the publication of ICI mode, the status of Himalayan glaciers, we have been very concerned with the melting. Recently, I approached Dr. Leslie Field of Arctic Ice Project that her solution could be used to save Himalayan glaciers. He has been working on saving Arctic ice sheet for. And along with Mr. Rituraj Fukan of the Climate Reality Project India, we decided to organize a symposium to communicate the urgency of slowing the melt of the Himalayan and Greenland glaciers and to avert catastrophic impacts, life and livelihood of billions of people. We are very fortunate to have His Excellency Olafur Ranker Grimsson support. This interactive webinar is a prelude to this symposium, which will be scheduled a few months later. Let me introduce the agenda. After my introduction, His Excellency Olafur Ranker Grimsson will talk about Greenland and the Himalayan ice melt. We are fortunate to have Sir David King say a few words on the topic. Then Dr. Mahendra Bhutyani will give a Himalayan perspective on climate change, its implications, and mitigation strategies. Then Dr. Peter Wadhams will talk about the need for interim solution to restore the Arctic, Greenland, and Himalayan ice. This will be followed by Dr. Leslie Phil going over the solution to restore the Arctic ice sheet and the potential of extending it below the melting of Himalayan and Greenland glaciers. Have allocated 30 minutes for Q&A, discussion, and planning. Few housekeeping rules. We have to do this. Keep your audio muted when you are not speaking. And please send your questions over Q&A. Try our best to answer. Now, it's my great honor to introduce His Excellency Olaf Ranker Grimsson. He was the president of Iceland for 20 years, 1996 to 2016. He now serves as the chairman of Arctic Council. For decades, Grimsson has been active participant in the global climate dialogue. During his presidency, he initiated and promoted clean energy projects in Asia, Africa, and Europe, the United States, and the Americas, especially using Icelandic model technologies as a model. With His Excellency, Grimsson is also involved in international cooperation on the ocean evolution of sustainable use of. Thank you. To you, His Excellency Grimsson.
Well, thank you very much indeed, and thank you for inviting me to join this very important dialogue. And I think it is both appropriate but also symbolic that we are meeting to discuss this at the same time that the global summit convened by President Biden is continuing into its second day. It is, of course, a monumental transformation of the global leadership. What we are hearing yesterday and will be hearing today about the commitment made by the United States, China, European countries, Russia, India, and others. And of course, the good news is that finally the global leadership seems to be coming together in an ambitious and realistic effort to prevent this transformation of the Earth ecosystem. But as I sometimes say to my American friends, yes, climate change is an important concept, but fundamentally this is all about the ice. And the ice is neither a Republican or a Democrat. The ice is simply melting. Whether it is the glaciers in the Himalayas, the Greenland ice sheet, or Antarctica. And the aggressive melting of the ice is perhaps the immediate threat to the safety and the security and the economic well-being of nations all over the world. If only a quarter of the Greenland ice sheet melt, it will lead to about 2 meters rise in sea levels everywhere in the world. And most of the monumental cities in the world are coastal cities. So this will transform the cities in Asia, Africa, America, Europe, everywhere on the planet. And the aggressive melting of the Greenland, of the Arctic sea ice is among the primary causes, as we all know, of the extreme weather patterns in America, in Asia, whether it is the snow in Texas, or the destruction felt in India and China. And of course, Pakistan, India, China, 3 nuclear weapon states, in addition to Nepal, Bhutan, and Bangladesh, are fundamentally threatened by the aggressive melting of the third pole Himalayan glaciers. All the major rivers of China and India originate in one way or another in the Himalaya third pole region. And the possibility for conflict among these 3 nuclear weapon states can be traced in a big scale to the melting of the Himalayan glaciers and the water systems, and how that will affect the plans for electricity production in hydropower, as well as the food production, which relies on the flow of these rivers. So my message has been for a number of years in the climate debate is to turn the issue towards the ice, because everybody understands the ice. That is a reality. And when I brought President Hollande to Iceland prior to the Paris Climate Conference to speak at the Arctic Circle Assembly, I took him some hours before to the edge of our fastest receding glacier. And instead of letting the helicopter land at the edge of the glacier, I let the helicopter land where the glacier was when I was born. And then I let the president and the entire French entourage and the French media walk for almost an hour across the black sands and the rocks until he finally came at the edge of the glacier. And then we reached into the glacier lake and picked up some ice rocks to let him feel it, let him feel the melting. And we can illustrate this in many different ways. And as was said yesterday by a number of people, and as has been the core message of Secretary Kerry, the special envoy to the president on climate, we are running out of time. We all know that. Time is of the essence. Time is of the essence. So any measure that could give us more time to adjust our economies and societies and the global system would be a gift of God, almost a gift of God. If we can slow down the melting of the ice until we reach the state of net zero emission and the glaciers on the ice can start to be restored, it would be, as I say, a gift of fortune or a gift of God. Our big problem is that the ice is melting. And with all due respect to NASA and every respectable scientific institution in the world, it is melting far faster than the most advanced scientific institutions predicted 10 years ago. So in that sense, the statement the scientists were wrong is true. It's true. I mean, they were wrong in their prediction of how slow the ice would melt. So we are now faced with a more aggressive melting of the ice than ever before. All of this I've now outlined was the reason why, when the first assembly of the Arctic Circle came together in Reykjavik in 2013, we convened a forum, a discussion, a dialogue, or a mini conference around the third pole issue. And many people were surprised. Why are you having a special meeting in the first assembly of the Arctic Circle on the glaciers in the Himalayas? And the reason was, first of all, there is a similarity between some of the glaciers in the Arctic region and the glaciers in the Himalayas. And secondly, as strange as it sounds, but it's still a reality, while China and India are observer states in the Arctic Council and are allowed to sit at the Arctic table, although there's some limits to how much they can speak, they're still sitting around the table. But there is no Himalaya table. There is no third pole table. There is zero cooperation among India, China, Pakistan, Bangladesh, Nepal, etc. So we were using the Arctic model of cooperation and scientific research and success to try to bring the Asian Himalayan countries together. And this effort has continued both through various assemblies of the Arctic Circle, as well as Arctic Circle forums, and through hosting the Third Pole Environmental Program, which is a remarkable initiative of Chinese, American, and European scientists involving the global scientific community. And we have now agreed with the government of the United Arab Emirates to hold in Abu Dhabi, once the pandemic is over, an Arctic Circle forum on the Third Pole and the Arctic, using the Arctic as an instigator to advance discussion and creating a cooperation among the Himalayan countries. And you might ask, why is the United Arab Emirates hosting such a meeting? The answer is that there are millions of people from India, Pakistan, and Bangladesh that live in the UAE. And if the glaciers continue to melt, there will be an exodus of their relatives and families that want to move to the UAE. So the population pressure of the melting of the Himalayan glaciers is not just felt in the third pole countries, it's also felt in the Middle East. In addition to their climate ambition that has led the UAE to take a lead in the follow-up from the Paris conference. And it is in this context, when I was sitting in this auditorium in California a few years ago, and Leslie came on the stage and described this extraordinary project, which she then called it ICE 9/11. Until I pointed out to her, nobody who doesn't watch American police programs on television doesn't know what 9/11 actually is. So I listened to her remarkable presentation that through her science, it was a possibility to slow down, give us more time, make the aggressive melting change its character. And I invited her to come to the Arctic Circle Assembly and present this extraordinary case, because I think it is a remarkable contribution to our effort, especially if it works. I'm not a scientist. I don't know whether it's going to work, but I have committed to trying to facilitate convincing the government of Greenland, and now we have a new government in Greenland, of allowing a certain territory of the Greenland ice sheet and the sea ice to be a testing ground. And if we can get even one Himalaya third pole country to do the same experiment in the third pole Himalaya region, it will be fantastic, absolutely fantastic. And the difference from the time I met Leslie for the first time in California a few years ago and where we are now is the global commitment demonstrated by the Biden summit of the urgency and the need to implement any measure that can either slow down the climate change, give us more time, and ultimately also help us to get down to net zero. So therefore, both I personally, as well as the Arctic Circle, is committed to bring our facilities and our influence, our network, in order to bring this scientific project to testing in real time, in the real world, of either Greenland or the Himalayas, or both. And I think it can be done. I think now the focus on the glaciers in the Himalayas and the third pole and on the melting of the Greenland ices is such that this is actually doable. Our task, however, is to come forward, or your task, with a sufficiently advanced and sufficiently practical and sufficiently scalable project that we can truly say, if the experiment works in Greenland and the Himalayas, that the world should now take this up big time. Because the limited time that is at our disposal means that every effort that we want to implement has to be scalable. We can no longer afford to spend a decade on sort of scientific experiment and see whether perhaps it will work sometime in the 2030s. That time is over. So our challenge now is to formulate the testing project in such a way that one can take it concretely to the authorities that need to approve such real-time, real area testing in both the third pole and as well as in Greenland, and then to communicate it to the global leadership immediately after we have the results. That is the reason why I'm here. That is the reason why both I and the Arctic Circle has committed to this partnership. And I will be very interested in the following discussion to hear where you are now, at what stage you are now, and how quickly you think this can be brought to the ground. Thank you.
Thank you, His Excellency Grimsson. It was wonderful to hear from you and your this problem. We appreciate very much. Our next speaker is Sir David King. It's my honor to introduce him in this forum. Sir David King is an emeritus professor of the University of Cambridge. He was a special representative for climate change to the Secretary, United Kingdom from 2013 to 2017. He was the Chancellor of the University of Liverpool 2010 to 2013, Director of Smith School of Enterprise and Environment, Oxford 28 to 2012, President of College of Carlo Alberto in Turin, Italy 2008 to 2011, and last but not the least, 1920 Chair of Physical Chemistry at the University of Cambridge from 1988 to 2000. Thank you so much for joining us. Please take it over.
Thank you very much, Sumitra. And let me first of all say how much I admire what His Excellency President Grimsson has been doing over the previous 2 decades and will continue to do over the coming decade, I'm sure. It's once again very good to see you. I'm just going to very quickly run through the big challenges that what is happening in the Arctic Circle represents for the whole world. So my first slide is based on what we know has been happening. As His Excellency said, the melting of the Arctic sea ice has proceeded far more rapidly than predicted. And my colleague Peter Wadhams is one of those who made the key measurements to demonstrate this. And so what we see is quite simply that Greenland is now surrounded by a blue Arctic Sea during the polar summer, and therefore Greenland is now losing its ice with once again a positive feedback effect. Why is all this happening so quickly? Let me very quickly say something about greenhouse gas levels. As I'm sure you know, the Intergovernmental Panel on Climate Change is very focused on telling us that today CO2 levels are at 415 parts per million. But of course, that's not the only greenhouse gas, and the emissions of methane are now rising more rapidly than carbon dioxide globally. And if we add in methane, and I use a steady state value for the equivalence between methane and carbon dioxide, we find that we're at over 500 parts per million, compared with 415 just with CO2. There's not a climate scientist I know from 20 years ago who didn't say we should never exceed 450 parts per million. We're way over that figure today. And what is happening in the Arctic Circle region is a follow through from this very heavy level of greenhouse gases in the atmosphere. So there in the center of my picture is what is happening to the polar vortex, that wind blowing around the North Polar region that tends to keep the cold air in and the warm air out. And that is now quite severely distorted, and that distorted vortex is now meandering. And so the Northern Hemisphere weather systems are dramatically altered as a result of this. And on the right-hand side, just a reminder that in the permafrost of the northern regions, there is a vast amount of methane captured as methane hydrates. And those methane hydrates decompose somewhere below the melting point of ice. And this has been observed to be happening. At the last meeting of the Arctic Circle region that I attended in 2019, for the first time we had Russians present. And the next slide shows what is actually happening in terms of methane emissions. If I could have the next slide. In the north of Russia, this is the Yamar region, these loud explosions heard by villagers some 200 kilometers away from where these explosions occurred have been occurring with the release of methane and water vapor. So the permafrost is suddenly ejected in a very loud explosion, leaving craters 50 meters diameter, 60, 70 meters deep. This is a picture of the future. It's not something we scientists could predict again, because you cannot predict explosions of this kind. But we are now worried that this may multiply many times over. It seems something like 1,000 of these explosions have already occurred. And so when we look at methane levels, we know what the origins are, escaping methane from oil and gas recovery and coal. We know that it's also from various farming practices, but now we've got a new big source potentially in the Arctic Circle region. However, we are talking about rising sea levels, and President Grimsson is absolutely right. So the next slide takes me on to say, well, when we 10 years ago, we scientists predicted on the basis of what we understood from rising sea levels, what would happen to Vietnam. We show on the left-hand side, this is 2050. This is in 30 years' time. Vietnam essentially flooded quite extensively by that time, and this was the prediction from 10 years ago. On the right-hand side is the most recent prediction. And we'll see that we're now predicting that Vietnam, 90% of that country will be flooded at least once a year in 2050. It becomes an unlivable country with enormous population. And the reason is quite simple, that Mekong Delta has been washing silt out over many thousands of years. And so the whole of that Vietnam area is very close to sea level. But the second problem is that this is a region of the world that suffers a large number of hurricanes. Hurricane intensity depends on the warmth of the seawater, the surface water, and the water is getting warmer. And so what we see is more intense hurricanes. The incursion of the water inland is therefore much further. I'm just showing here in this picture Vietnam. But let me tell you, the Southeast Asian region by mid-century is severely at risk from extensive flooding. So the cities of that area, you see here at the top right, Ho Chi Minh City, these cities will suffer severe flooding. Jakarta this year, January this year, suffered very severe flooding, the whole city. And now in Indonesia, the government is planning to move their capital to higher ground. So we look around the region. His Excellency mentioned Bangladesh. Bangladesh, 2/3 of Bangladesh will be underwater by this time. And of course, over the Ganges mouth from Bangladesh is Calcutta. Calcutta also will not be a livable city by mid-century. We're talking about cities with 11, 12, 15, 20 million people. And if I talk about Jakarta, that is, anyone who's been there will know, is a modern, bustling city with very new buildings, all emerging because of the rapid economic development of that region. That will be a wasted investment. But worse than that, we're looking at a region of the world where there will perhaps be 100 million climate refugees looking for somewhere else to live. But at the same time, other major coastal areas of the world will also be suffering from frequent flooding. So the need for rapid action is absolutely clear now. Let me take the next slide. All of this is the reason I've left government in 2017 to form the Centre for Climate Repair at Cambridge. The centre is now up and running, and we're working globally. We're a hub working with universities around the world, working with the political communities around the world, working with financiers to achieve the objectives set out here. And I'm saying that these objectives must supplant and supersede what is being negotiated over COP26 going forward in time. So let me say why. Deep and rapid emissions reduction, without that, frankly, we're cooked. We have to do this. But we also need to create full-scale greenhouse gas sinks. Excuse me. We need to capture, I think we could capture 30 to 40 billion tons of greenhouse gases from the atmosphere every year. And I'm saying this at a relatively low cost, relative to the cost of not doing this action. Quite frankly, humanity is severely at risk unless we do this. So my objective there is to persuade everyone that we need to get that figure of greenhouse gases down from 500 parts per million today plus to less than 350 and as soon as possible. I don't think we could do it before the end of the century. And therefore, third point, exactly what His Excellency said. We need to buy time by refreezing the poles. And I'm going to describe the Himalayan glaciers as the third pole of the Earth. So I'm going to say, yes, we must find methodologies to refreeze the poles. Here in Cambridge and working with colleagues around the world, we are also developing a methodology to refreeze the Arctic, and this is now moving rapidly into quite an advanced state. If there's time for questions, I'm happy to give some indication as to what our approach is to that. But the fourth thing is that we need to promote agile political research, business, and investment responses. We need action over the next 5 years to see that we put in place everything that's needed to achieve these objectives in a very short period of time. We have been talking about this problem since 1992. I've been heavily involved over the last few decades in this process, particularly in the negotiations. But I think what is needed now is a complete change of positioning. Of course, I welcome the meeting that is taking place under the aegis of President of the United States. I also welcome the fact that Chinese president is also very keen to play a leadership role, because between China and the United States, if those two countries, together with India and Africa, join the rest of the world in significant actions, only then can we manage the first of these, deep and rapid emissions reduction. In the meantime, we need to get on with greenhouse gas sinks at scale, and we need to get on with buying the time by refreezing the poles. Thank you.
Thank you so much, Dr. Sir David King. It has been such an honor and such a small, short time you could join and give us a talk on this topic. This is remarkable. Thank you very much for your presence. Our next speaker is Dr. Mahendra Bhutyani. Dr. Mahendra Bhutyani will speak on Himalayan perspective on climate change and its impact on the region. Dr. Mahendra Bhutyani was a director, retired now, from Defense Terrain Research Laboratory, India. He was the head of the Department Geology in College of Military Engineering, Pune, India, 1992 from 2010. Was a scientist at Defense Research Development Organization in India at Snow and Avalanche Studies Establishment, Manali, and carried out research on response of glaciers to the climate change and its implications on Northwest Himalayas and natural hazards and their mitigation in Karakoram Himalayas. Authored over 61 research papers on glacier response to climate change, glacier mass balance, and hydrology of long glaciers in Karakoram Himalayas. Thank you so much, Dr. Mahendra Bhutyani.
Thank you so much.
Please take it over from now. Thank
I'll
you.
share. Thank you so much, Dr. Mitra. Thank you so much. I'll just share my screen now. Can you? Just one sec. Can you show my presentation, because
Uh,
I had already mailed to you.
Rituraj, can you share that?
Just few minutes.
Maybe while you are working on that, we can move on to the next speaker.
That will be better. I'll just find out, because I had sent that by mail to him.
Our next speaker is Dr. Peter Wadhams. He is going to speak on the need for interim solutions to restore Arctic, Himalayan, and Greenland ice sheets. I am honored to introduce Dr. Wadhams. He is a professor of ocean physics and head of the Polar Ocean Physics Group in the Department of Applied Mathematics and Theoretical Physics, University of Cambridge. He is the UK's most experienced sea ice scientist with 40 years of research in sea ice and ocean in the Arctic and Antarctic. Led 46 research expeditions to the polar seas and carried out 6 voyages to the North Pole from 1971 to 2000. He is also a pioneer in the use of autonomous underwater vehicles. Please welcome Dr. Wadhams. Thank you, Dr. Wadhams. Over.
Thank you very much. I have to share my screen as well, so let's just see if that works.
Can you make it co-host?
Can you make me a co-host?
You should be able to share the screen Peter. I can share it if we.
Here we are.
Okay,
Okay.
great.
Right. Let me say at once, I'm not showing all of these slides. Here we right. So what I'm going to talk about is the intermediate step between restoring and saving the ice in the Arctic, in the Himalayas and in the Greenland ice sheet, and doing nothing. That is, what can we start to do that will help us to buy us time for the large scale climate carbon dioxide removal that is going to be needed to give us a long-term solution for all of these three ice masses. And so I'll look briefly at the three regions concerned, which David's already really gone through that, and then look at the interim solutions. Fortunately, the most useful one for Arctic ice is actually one which Leslie has developed, and so I'll leave it to her to talk about that one. Okay, first of all, of course, I advertise my book and the film, I mean, mainly because this deals with all the feedbacks that occur when ice disappears. And I recommend the film that came along just a little bit afterwards by Leonardo DiCaprio called Ice on Fire. And this shows quite graphically, in fact, on the cover, a scientist who stuck his ice axe through the ice of a frozen lake in Siberia, which has methane underneath it, and the methane came out, and the result of applying a naked flame is this. Right, well, first of all, the problem is that everything that we've done has been essentially meaningless as far as reducing carbon dioxide concentration is concerned. And this is where we're in a rather dire situation, which we have to take really serious action to put right. The carbon dioxide level at the top of Mauna Loa volcano in Hawaii started to be measured in 1958 by Keeling, and this has continued to accelerate ever since. And it doesn't matter what we've done, or especially what politicians have said, that the CO2 level has continued to accelerate upwards. And here, against that curve, we see all the official meetings that have been held in attempts to reduce the rate of CO2 increase. These are the COP meetings, of which we're about to have another one in Glasgow this year. And nothing seems to have had any impact at all on the exponentially rising CO2 levels. And this is a real cause for worry. If we look at the individual gases which are responsible, they all have shot up since the Industrial Revolution, because carbon dioxide and methane are the two main ones, but there's also nitrous oxide and a few others. And if we want to understand the magnitude of that, we only have to look at the curve for the carbon dioxide levels since over the past few ice ages. This is 500,000 years of climate history. We see that the CO2 level rises in interglacial periods to some natural level which the Earth seems to like, which is about 280 parts per million. But what we've done is to take that interglacial and turn it into something that's taken us over 400 parts per million. So that's a drastic intervention with the planet. So when people who object to geoengineering, for instance, doing things to the climate to try to slow warming, and they say this is, we can't do this because it's an intervention with nature, it's messing up the planet. But I don't think there can be any messing up of the planet as great as what we've already done by increasing carbon dioxide levels to such a huge level beyond anything which the planet has experienced for several million years. Well, that's what's been happening. And what it's done to the Arctic ice is to take it from this kind of formidable, impressive looking type of ice called multi-year ice, which used to prevail in the Arctic Ocean, and some of which used to get down as far as Iceland, to what we have now, which is purely first year ice, which is smooth, flat, thin, and quite dangerous. These are Inuit hunters from northwest Greenland, and they, in a project we were doing with the EU, we fitted radar to the bottoms of their sledges to give a warning if they were running over thin ice, because their sledges have been falling through the ice. So this gives them a warning and gives us some data. So that's what's happened to the sea ice. Certainly, it looks completely different from what it used to. It's a really a different material. And the summer retreat of sea ice, which happens in September, took us in 2019 to almost a new total minimum. And in 2020, it actually has climbed since the summer very, very slowly up. And it's not just that the summer sea ice is about to disappear, it's that the sea ice in every season of the year is now down at record lows for that season. So the whole of the Arctic sea ice cover is shifting downwards in area, whether you look in the winter or the summer. And so here's the summer, and we see how much less the area is than it used to be in the 1970s. Because we've been measuring the thickness of the ice as well, in my case with submarines, we can get the volume, and the volume decrease is even more dramatic. This is the volume in summer has gone down by 3/4. It's now only about 1/4 of the ice volume that we used to have in the 1970s. And methane has been going up recently as well. It started to take off, and we wonder why, and we think it's because of the increase in methane release from the Arctic. Now, nobody knew what was causing this until 1896, and now since 1896, for the last 125 years, we've had no excuse for not knowing what's been causing the rise in temperatures. It's CO2, it's the release of CO2 and other greenhouse gases into the atmosphere. And this was really first explained properly by Svante Arrhenius, a Swedish scientist, who in fact is the great uncle of Greta Thunberg. And he got the calculation of how much warming there'll be per unit emission quite accurate, but he didn't raise the alarm because first of all, scientists have had an unfortunate tendency not to raise the alarm when they should have done, but also because he thought that nearly all of that CO2 would dissolve in the ocean, and that would mean that it would be out of not doing any harm. But of course, that was wrong. So that's the Arctic Ocean. Now we look at the Himalayas and what's called the third pole, actually the area of ice sheets and glaciers in the center of Asia, and that's about it's about 30 million square kilometers. It's about to be lost. A lot of it is about to be lost. The calculations are that if we can keep warming down to 1.5 degrees, then about 1/3 of this region will lose its ice by the end of this century. If we don't keep the temperature down to 1.5, then 2/3 of it will lose its ice. It's a huge area. Here's a nice one of the glaciers on the eastern part of that, the Mignon Glacier, and that's the one on the eastern side. But we hit this slide shows all of the rivers that drain from this plateau, and there are about 10 major rivers. All the major rivers of East Asia drain from this plateau. So we've got something like 250 million people living within this region, but we've got about 1.7 billion people dependent on the rivers that flow from it. So it's a very, very serious problem if the river flow is changed by melting of the ice on the plateau. This shows the very top of the highest, one of the highest points, and near Everest, and again melting ice. So that's the Himalayas. Then the Greenland ice sheet is the third area, and I was just fortunate to be standing on that ice sheet on the day on which it had its biggest loss ever. 12.5 billion tons of water melted in one day, largely because the air temperature on that day was 21 degrees C, which is a pretty unprecedented temperature if you're 3,000 meters up in Greenland. Normally, you wouldn't expect any melt at all. But when you see that level of melting, you see how it's altered the ice sheet. All the snow has gone, and the most telling of all is the fact that the ice sheet has gone black. And I think, as David has said, this is a very, very serious problem because you're reducing the albedo of the ice sheet very significantly. What's happened is that as the ice sheet has melted more each year than it's gained, the ice crystals turn into water, they drain away, but the dirt remains, and that dirt is a mixture of soot from fires, organic material, and dust coming from as far away as the Sahara. But it produces this substance called black ice, which has a very low albedo. And in fact, if you try walking on it, you find it's not slippery at all. Here, it completely coats the ice sheet with this brown or black layer. And here we see that happening at a time that the ice itself is melting at a record rate and producing fierce rivers flowing down out of the ice sheet to the open ocean. This is one of the sources of this, which is now increasing in magnitude, which are the brush fires in North America, in the Arctic, and itself, in fact, but here in California, in Pasadena, a place you don't expect to catch fire. And the rate at which the Greenland ice sheet is losing material is increasing. This can be measured by gravity satellites. And as David's shown, the whole of the ice sheet now tends to have a melting surface in summer, while in the past, very little of it was, just the lower levels. One prediction of that, again, is that the Intergovernmental Panel on Climate Change has been constantly uprating its predictions about how much sea level rise we're going to have by the end of this century. This was their very bad prediction from 2007, but it's gone up, and it's gone up even more recently from glaciological work that was being done on particular melt features in Greenland, and was being done most intensely, I think, by Connie Stephan, a very great glaciologist who unfortunately was killed last year in an accident on the Greenland ice sheet. But his estimate, which he was just about to publish, was that we'll have 4 meters of sea level rise by the end of the century, not 1. How do we try to do something about this? Well, with Greenland ice sheet, all of these, it's a problem. And I can suggest 2 or 3 things that can be tried, but it's not as simple as it looks. Firstly, with the Greenland ice sheet itself, you want to get that ice whiter. You want to increase the albedo. So here's a place where maybe the system that Leslie's been developing for sea ice could be applied to the ice sheet. A method that's been used on ice glacier regions in Europe is one which I've done some calculations on, and it's just too expensive, which is to use a kind of unwoven fabric which you can roll out in very large swaths with a tractor, and it will cover a glacier or a slope, more likely a ski run, and slow down the melt, or prevent it from melting during the summer. And this has been suggested also as a way of preserving icebergs if you want to tow those to warmer countries. But looking at the cost of this unwoven fabric, it's really very, very high. So you want something that will be less expensive than that. Another way that will get at the ice, the ice on the sea, has been marine cloud brightening. This is something developed actually in Britain by Latham and Salter in Scotland, and it consists of taking a drone ship and pumping seawater up through a very fine nozzle into the bases of marine stratus clouds, which are those grey miserable clouds you get in Britain and in lots of other places. But if you have a suitably fine nozzle, the particles that go into the cloud brighten the cloud up. It's called the Toomey effect, discovered in 1970. And this will mean that the clouds that are heading for the Arctic, if you put it into the right regions, that's the upwind of Arctic locations, that brightening will cool the atmosphere and will allow, at least according to calculations, it will allow sea ice to expand, and we'll get larger areas of sea ice, not incredibly much larger, but significantly larger enough to give us some respite. This method has also been tried by other people. You can do a similar thing, but many people think it's more dangerous, which is to release aerosol into the stratosphere. This does the same job of increasing the albedo of the planet, but because it stays in the stratosphere for several months, you have to accept what it does to you, which might be something nasty to the monsoon. Whereas with cloud brightening, you can switch it off and it immediately stops. So these are 2 techniques. The third technique, though, the final one I'm going to mention, is the use of a method called iron salt aerosol. And this has been developed with one specific end in view, which is that there is a direct threat to the planet at the moment from methane. And there's a huge methane, as well as the methane that David's shown, the very large methane explosions going on land. There's been a large amount of methane emissions going on from the shallow coastal seas around the Arctic, at least Siberian Sea, Laptev, Barents Sea, all these shallow 100-meter deep seas. And when we look at them, we find they're already emitting large amounts of methane. This is a picture taken from a sonar system looking sideways, and it's water only 70 meters deep, emitting methane gas. The methane was contained in the sediment, and it broke free when the seabed sealant material, which is kind of frozen ground, thawed out and allowed this methane to come up and enter the atmosphere. this is getting more and more frequent. Every year that you go up there, there's more of this happening. And it's very, very dangerous, of course, for a ship passing overhead, if you have any naked lights. But it's much more of a problem for increasing the level of methane, possibly in a sudden burst, because if the protective layer of the seabed that prevents methane coming out, if that is breached, you could have a very large methane release in a very short time, giving us a step change in global warming. So a way around this, which is being researched at the moment, is to use an aerosol made of iron powder, which is blown over the surface of the sea and reacts with the methane to give you a methane chloride, which then falls out and is lost into the ocean. So it's not clear whether this actually works properly. The experiments are still going on in Copenhagen University just now, but it's a possible solution, and we certainly need an interim solution here to, if we get, because we could get a methane outbreak very soon, in any time in the next few years, and we need to be ready for it. So these are the interim solutions, but of course, the ultimate solution has to be, as David says, getting rid of carbon dioxide. And the interim solutions are all, how do we try to fend off the worst effects of global warming until we can really get enough CO2 removal deployed. So I'll now let Leslie explain another method of removing, of increasing albedo from the ice surface.
Thank you, Peter. It was wonderful presentation. We learned a lot. Every time I hear you, I learn a lot. Thank you so much. Our next speaker, we go back to Mahendra Bhutyani. Hopefully, the slides can be shared this time. While he's getting ready, I can ask a question. There are a lot of questions that are coming. Peter, if you stop sharing the screen, then you'd be able to. So one question coming from Lieutenant General Shani. With this example of Vietnam, what will happen to the artificial islands created and militarized by China in South China Sea? Any taker?
I guess that's a question for me to answer, and I would like to say this is probably the least important question that should be asked about this. Rising sea levels is going to be so dramatic in terms of the number of people who will be unable to live where they normally do. What will that do? 100 million refugees to the rest of the world? But more than that, I showed a picture of the Mekong Delta. Mekong Delta is the biggest series of rice paddy fields in the world. One period of flooding with seawater and they will no longer produce rice. Indonesia is the other country, is a big, big source of rice for those countries around there. Much of Indonesia is very close to sea level. Much of Indonesia will also be flooded by the storms at sea flooding inland. So I think the biggest challenge there is the human challenge associated with that. The Chinese islands, I'm sure they know how to build higher islands. If they can build islands of a given height, I'm sure they'll just raise them.
Thank you, Sir David King. I think our presentation is ready.
Is my screen visible now?
Yes, let me have the pleasure to introduce Dr. Mahendra Bhutyani. I think we already did that. Go ahead, take it over, Dr. Bhutyani.
Is the presentation visible?
We can see it.
Thank you, Dr. Soumitra and His Excellency Dr. Grimsson, for giving me this opportunity to talk to you about the Himalayan perspective, how climate change has played out in the Himalayan terrain, what are its manifestations and what are the implications it has got, and what are the different mitigation strategies we have thought of. Simple strategies, some advanced strategies which may work on the advanced technologies, but definitely there's a need to sort of preserve the Himalayan ecosystem because the climate change is taking a very heavy toll there. Well, as far as the climate change and manifestations are concerned, it has definitely affected the flora and fauna in the Himalayas. Definitely, there's a tendency to have the tree line going up and up. Of course, I'm not going to the details. Then there are basically temporal and spatial variations in the temperatures. The temperatures have risen substantially, which I'll discuss in the subsequent slides, and the precipitation patterns have also varied. That has resulted in thawing of the permafrost, which has resulted in the recent disaster that we had in Chamoli, which was basically as a result of thawing of the permafrost, and of course the shrinking of the seasonal snow cover. The changes in the glaciers are quite evident. The glaciers, barring few glaciers, I must say, barring few glaciers in Karakoram, most of the glaciers, they are following a global trend, which is basically the recession. Most of the glaciers are receding and some of them are advancing, but they have got different reasons for them to advance, which I'll discuss in a nutshell, definitely. Then it has also caused certain changes in the hydrological regimes of the Himalayan rivers. Well, I'll not go to the details, but we have found that in our studies, there is a tendency towards reducing annual discharge of the rivers. The river discharges have started decreasing. Well, there was a time when the discharges were increasing, and they increased up to a certain point, which happened to be an inflection point. Well, the early 90s happened to be an inflection point. And after that, all the rivers in the Himalayas, they are showing a decreasing trend in the annual discharge. But the flood discharges, the maximum flood discharges, they have increased as a result of increase in the intensity of high rainfall events as well as the high magnitude flood events, of course. And all this together, they have brought out a lot of changes in the characteristics of natural hazards which are being experienced in the area. There are a lot of manifestations. I'll subsequently in my slides, I'll have to rush to my slides. Well, this is what we have found in our studies, that the winters have warmed substantially. As you can see here, the winter, the warming is almost 1.7 degrees on a century scale, which is almost 2.5 times than the global average. The monsoons have also, monsoon periods, they also warmed up, but not as substantially as the winter. So winter warming is substantial. And because the winter warming is substantial, it has affected the annual warming also. The annual rate of warming is almost 1.1. That is on a century scale, that I'm talking about century scale. Well, this has actually led to a lot of variations in the snowfall cover. The winter warming, as a result of winter warming, the snowfall amounts have decreased in different ranges. The Pir Panjals, then we have Greater Himalayas, then you have Jaskars, then you have Ladakh. Almost all ranges have shown a decrease in the snowfall component of the total precipitation in the winters. I'll not go into the details, but this is what has been observed. And it has led to sort of the onset of winter, which is quite early. The November months, almost they have warmed up substantially. And of course, the spring has set in very early. The March temperatures have warmed up substantially. That has given rise to a typical effect that we call, basically we have given a name to it. This is basically the mountain spring heat island event. It's a positive feedback from the receding snow line and the exposed ground, and both of them trying to interact with each other and giving rise to more rise in the temperature, the winters getting affected, and the snow line receding further. So this is what has actually led to what we call, what we are given the name to it as a mountain spring heat island effect. And this is basically, the graphic shows how the snowfall patterns have changed over a period of time in different ranges. This is first two graphs are basically the Pir Panjal ranges, then different ranges. The last three ranges, they are showing almost no change. That means the temperatures have risen in Himalayas, no doubt about it. But thing is, different ranges, there is a spatial component to it. Different ranges have shown different levels of rise. Some of them have shown cooling also. In fact, the Pir Panjal range, particularly the southern aspect, the windward side, it has given rise to a tremendous amount of warming, particularly in the Pir Panjal range. Then, of course, these areas, basically, they are showing almost, some of the stations are showing rising trend, some of the stations are not showing any trend at all, then these stations are showing a very rising trend. And of course, after a certain altitude, particularly in the glacier Himalayas, Karakoram Himalayas, all stations in the Karakoram range, particularly above an altitude of about 5,000 meters, they're showing a decreasing trend. There's a different reason for that. So this is how there's a spatial component attached to the warming process of the Himalayas. There's a temporal aspect also, there's a spatial aspect also. And what happens?
Excuse me, sir. So your slides are not changing. They seem to be fixed at the first two slides. Can you please check?
I don't know. Yeah, as far as is it there? No.
Yeah.
We can see the slides, but
I'll have to reload the presentation again. Just 1 second. I think there's some. Is it there now?
No, maybe we can move on with in the interest of time. We can go ahead without it. And
as far as my PC is concerned, I think I'm getting that particular variation.
No, if you stop sharing, sir, maybe I can share it from my side, and then we can jump to the slide, whichever slide you want to go.
Okay, what I'll do is.
Yeah, if you just.
Is it visible? No.
No, we are only seeing a screenshot actually of the presentation, not the presentation itself.
No. In fact, as far as my this is concerned,
Dr. Bhutyani, if you could stop sharing the screen, then Rituraj do that.
I think Ruturaj has got my presentation. If he can again reload it.
Yeah, I can share. If you stop sharing, I can share your presentations. Well, now we are seeing some slides.
I know it's coming. Okay. So I'll just recap. So this is basically what we have found. I mean, these are some of the manifestations which we have already discussed. This is what our data says. In fact, our studies on a century scale has found the temperature rise to be almost very alarming, 1.7 degrees on a century scale, particularly in the winters. Then, of course, the annual, actually the average annual is basically almost 1.6 degrees on a 100 per 100 years. But and whole thing has given rise to what we call as the snowfall component being decreased in the total precipitation. So winter has onset lately because the November temperatures have increased substantially, whereas the spring has advanced substantially, basically as a result of March warming, substantial March warming, and as a result of that, we have got a typical effect where we call that effect as a mountain heat, spring heat island effect. Is basically a positive feedback mechanism between the receding snow and the exposed ground, and each other leading to the effect that every year there's a recession of snow line. So this is what we have sort of got some findings where the snowfall has been regressed with the temperatures. With temperature rise, the snowfall component has decreased. But these two graphs, they showed a really good statistically significant decrease. These two graphs also, but last three stations, they hardly show any effect. So this is basically, that's what I said, there is a sort of temporal as well as the spatial component to the warming. Some of the ranges of the Himalayas, they have warmed up substantially, particularly the Pir Panjal ranges, and within the Pir Panjal ranges, the windward side, the southern aspects, they have warmed up substantially, whereas these stations in the rain shadow region or in the leeward side, they have not warmed up, they have not shown any visible effect of temperature rise, whereas these stations have shown substantial rise, and some of the stations in the high altitudes, particularly beyond 5,000 meters, they have shown a decreasing trend. So all these places where you have the rising trends, they are almost inhabited, and there's a lot of anthropogenic activity, I must say. So as far as the glaciers are concerned, well, the specific mass balance, almost all glaciers, I told you earlier also, barring few glaciers in Karakoram, most of the Himalayan glaciers are retreating and they're showing a negative mass balance. So that means they're melting more. and the glacier melt component of the total discharge was increasing, but it reached an inflection point somewhere in the early 90s. And after that, the glacier melt component in the total discharge has gone down. And as a result of that, most of the rivers, particularly in the Himalayan terrain, I'm talking about Bias, Satluj, Chenab, Ravi, and if you go further, these are the rivers which have shown a decreasing discharge. This is how the basically all glacier retreats are there. We have been able to do some analysis of Siachen also. This is what typical how Gangotri has receded. This is how basically Siachen has retreated in last, let's say 15 years. And after that also we have carried out the analysis. So this is the South Terong. This is one of the tributaries of Siachen. The Siachen Glacier, this is a ground photograph. You can see there's a lot of recession of the snout. When I started working in that area in 86, it has gone, the snout has gone almost here. And most of the moraines are now, they're substantially thinned. You can see this particular, the snout, the thickness of the snout used to be here. Now it has substantially thinned. Same is the situation as you go slightly upwards, where the glacier thinning has occurred substantially. This is with reference to Siachen. There's another tributary of Siachen, which has advanced. Now this is the North Terong, basically. And it has shown a sort of a mini surge in that particular glacier. Well, that is that particular glacier has shown some advance, basically because of certain other reasons, because of certain issues, because it received a huge rock avalanche, particularly during the 2002 or something, and that rock avalanche triggered a mini surge. So, and there are similar glaciers which have got their own reasons to surge, but majority of the glaciers in Karakoram as well as in the Himalayan terrain, they are melting fast, they are showing a negative mass balance, and they are also retreating. So of course there are a number of reasons why the Himalayas are warming. Was a significant level of urbanization, human activities, anthropogenic activities, then per capita consumption of the petroleum products. There are so many reasons which has led to the greenhouse gases. And as you can see, some of the photographs which are very, very alarming, where there are hardly any Himalayas left out. I mean, the whole area is covered. It appears it's covered with the built-up areas now. So there are rooftops which have been covered. A lot of inhabitation has come up at the cost of deforestation and basically and as a result of anthropogenic activity, which has led to a lot of movement of vehicles in that area. All that very fragile ecosystem of the Himalayas is now vulnerable to the kind of the emissions that are coming out of these vehicles. And in fact, you can see, and the kind of people that are visiting the high altitudes of Himalayas, which has led to the formation of a lot of carbon soot particles on the snow, which has resulted in the early melting of snow. And of course, as a result of the typical positive feedback mechanism, the spring heat island effect, now the snow line is receding almost on a regular basis annually. Now, this is the situation we have landed ourselves in. Can there be a way out? Can we salvage that situation? And yes, what could be done? We'll try to talk about certain mitigation strategies. Our strategy should address the following issues. We have to somehow think of this winter warming, which is at a very alarming rate. Can we decelerate that abnormally high rate of winter warming? Can we stop depleting winter cover? There's a very loud thinking, but definitely the ways and means have to be found to think of all these aspects and come out with the solutions. And can we restore the health of our receding glaciers? Well, as there are certain simple solutions, there are certain complex solutions also. There are certain simple solutions which are being resorted to, which are being now implemented on ground. But the options, basically, the first and the foremost, as Dr. Grimsson has talked about, Dr. King has also talked about, these are renewable, low carbon sources of energy. We have already started some work in the Leh Ladakh area. The hydropower is also being exploited to a large extent, the wind power and the geothermal power. Geothermal power at some stations, definitely it has got a lot of capital investment, but definitely it has given us some hope with regard to the mitigation strategies. These are some of the micro hydro projects which have come up in that area. This is the geothermal energy which has to be tapped. And this is what we have done at Manali, where we have a establishment, we have on an experimental basis installed the one geothermal pump, basically, and the heat from the ground is being tapped for storage heating and some other minor application. But this is on a basic experimental basis, and it has successfully worked to some extent. There are certain problems, operational problems. There are certain issues with regard to the technology also. But this is an experimental basis. The geothermal energy is being tapped. But we can always talk about a hybrid solutions, the hybrid system where we can integrate some of the renewable sources, generating systems, and to meet the local requirements, and particularly use hybrid systems. Basically, you can use wind along with solar, wind along with thermal energy. And this is actually something which has to be done, which cannot be denied, which has to be resorted to, because the situation is alarming. See the kind of vehicles that go to the altitudes of Himalayas, particularly during the summer when a lot of tourists visit that area. You can see and imagine not one single vehicle is turned off. Every vehicle is belching out lots of greenhouse gases, ozone, carbon dioxide, carbon monoxide, and they're affecting the fragile ecology of the Himalayas. So this has to be somehow done away with. So we have to think of this solution, and with a lot of cajoling, with a lot of coaxing and all, some of the governments have agreed, the Himachal government and the Uttarakhand government. So there are now CNG buses running basically to the Rohtang, and actually there's a ban on the cars, and to a large extent the tourism has been controlled. Well, then there's another way is basically controlling the tourism. Now this is a mitigation strategy we have to adopt if you want to save the Himalayas from going to the disaster areas. So the ropeways basically, and this also they have thought of, they are building some of the ropeways at different places where the tourists are likely to visit those areas, and those areas are basically now they're ready with some of the renewable sources of energy, the ropeways and all. And there's one more issue which I would like to highlight here is basically the managing the wastage heat, particularly in the high altitude areas. There's a lot of wastage heat produced because of the vehicular traffic, because of the cookhouses, the dhabas, the hotels, and they all belch out a lot of carbon soot particles. And as a result of lots of animals are there, you have got horses, you have got sheep and all those. Then there's the excreta of all those animals, they create a lot of methane production. This creates a sort of mass wastage of the heat basically, and that has to be stopped. So with a lot of coaxing, we have been able to get those governments to ban those dhabas at places called Madi and Rohtang and all. There are no cookhouses there, and basically the tourism has been controlled to a large extent. Vehicular traffic is controlled, and to some extent, of course, it's not enough. I know the black carbon soot particles being belched out of the vehicles, they have reduced. See the kind of people they will sort of, particularly during the months of July, August, they visit and they create a lot of garbage around, a lot of greenhouse gases, then methane gases and all. And that is the result, that results in the early melting of the snow and the glaciers basically. Because if you have early melting of snow, the glaciers don't grow. The whole entire annual mass balance of the glacier is dependent on the winter precipitation. The winter precipitation itself is decreasing, and it is ablating more in the summers. As a result, we are going to negative mass balance of all glaciers. If we can manage to sort of get the snow stick on the topography, get the snow stay there for a longer duration of time, if you can manage the microclimatology of the various basins, well, we have achieved the aim of restoring the health of the glacier. So this is the kind of things which are happening as a result of a lot of anthropogenic activity. So this is basically now what is the way out? In fact, if you want to restore the snow cover and the glaciers, you have to identify those basins, particularly those areas where this heat, mountain peak heat island effect is very, very profound, and it has got very dangerous effects. And this is after identifying these basins, you have to think of some strategies. One of the most important strategies which we have thought of is basically the roofing material which is being used by the households there. If you can think of, like, it is a very sort of proven method, particularly in the North America, they've used, and other countries also. If you can sort of use reflective material as a roofing material, well, it will definitely alter the mass energy balance of the particular basins, and particularly during the winters, and that might lead to the certain drop in temperatures in the localized areas. It may not be on a regional scale, but definitely on a regional scale, on a basin scale, it might alter the microclimatology of the basin. So these basically are the basically suggestions we are given. Rooftops, a lot of urbanization is taking place. Lots of villages have come up, and they are also growing. The population is growing. So every rooftop has to be painted with white, or it can be painted with a reflective material. So this is the kind of deforestation and the urbanization which is leading to a lot of changes in the microclimatology of the basins. Well, you can see a lot of houses have come up, and at the cost of deforestation. If these houses are painted white, or they are provided with the reflective material, definitely it will affect the basically the microclimatology of the basin. Definitely it will affect the energy balance, particularly the winter energy balance of the basin. This is one study we carried out, how snow cover has, particularly in the Bias area, how snow cover has reduced by almost 30%, and how the urbanization has increased almost by 100%. But it is very minuscule if you compare with the snow. But definitely, because this urbanization along with anthropogenic activities, it has got a multiple effect. It has got a sort of a lot of effect on the microclimatology of the Bias basin. If we can check this particular thing, and if we can find out some methods by way of giving reflective material, well, definitely it will alter the energy balance. And we have to now think of some active methods like carbon capture, scrubbers. Now they have to be there. There are different scrubbers being used all over the world. India has to start using huge scrubbers at the mountain tops. So this is the only method by which you can talk about carbon capture, carbon sequestration, as Dr. King has already brought out. So they have already done it outside, but why not India? The Himalayas are going to the disaster areas now, and a lot of disasters are occurring. So we have to think of some methods by which you can talk about carbon capture, some active methods, some not passive methods, some active methods, and carbon sequestrations like this. They're being done outside also. And definitely, there are quite a few technologies available where direct air captures can be done, and that might definitely lead to a lot of reduction in the greenhouse gases. And this is the most viable method which I have found, that as compared to the other methods, therefore three, four methods of mitigation, but this method basically works, and this has got a lot of implications, particularly in the Himalayas, because it doesn't take a lot of water, it doesn't take a lot of space also. So again, after that, basically the fourth method, which is basically being implemented on ground and is also recommended for the entire Himalayas, is the snow harvesting. There are different ways and means of doing the snow harvesting. You can dig the snow pits, snow fences, check walls. Basically, idea is to retain the snow on ground to the extent possible. Let the winters extend themselves up to the April, as they used to be in the earlier olden times. Now they are up to the March. The snow cover is not there even in February these days. So somehow by way of artificial methods, by way of snow pits, check walls, we have to retain the snow. The avalanches can be controlled. Of course, they are very capital intensive methods, involve a lot of money, but definitely sometimes the solutions are expensive, but they have to be resorted to. The formation zone avalanche control structure, they might retain the snow in the upper reaches and the catchment dams in the particular runout zones. Then artificial release of aerosol particles, they are again a very dicey method, but definitely it can be resorted to in the Himalayas. The Himalayas are unique, and they are actually sort of vulnerable. So they are warming at the rate which is almost twice or thrice than the global average. So they also need some unique solutions also. So this is where basically you can talk about the avalanche control structures, and these in the runout zone, in the formation zone, where the snow can be retained for a longer duration. There are some of the methods which, they have, formed artificial glaciers by diverting the winter water into these nalas, which are basically having a northern aspect and which always remain in the shadow, and the temperatures are sub-zero, and they can create artificial glacier out of it. So this is the way they can sort of extend the duration of the snow cover and ice stupas, and there are some of the methods which are being followed, which are being adopted in the Himalayas. Now, to conclude my presentation, is basically there is a perceptible evidence of climate change. So we have to think of arresting this particular warming trend in the Himalayas by taking care of snow cover and the glaciers. rising temperatures, definitely they have affected the discharge patterns. Long term, there is a decreasing discharge, and definitely on the short term, the intensity of high magnitude floods has increased. Snow harvesting and the rain harvesting, they seem difficult. Definitely, they are the remedies which have to be adopted. And of course, as a result of this changing nature of the temperature and precipitation regimes, naturally, the geomorphologic hazards have also started changing the characteristics. Like in Siachen, we have got earth flows. In Siachen, we have got debris flows, which were not even heard of earlier. Now, ice avalanches are occurring on a regular frequency. The recent Chamoli disaster, basically, it was a huge permafrost degradation where the whole ice apron broke away, and it gave rise to a tremendous amount of heating and tremendous amount of discharge, which gave rise to a flash flood downstream. So all these are basically the hazards which were not even heard of in earlier times, but definitely in the spectrum of climate change, they are making their presence felt. So as Dr. Grimsson also brought out, yes, there is a need for urgent unilateral and proactive methods. The India cannot rely on others. Let there be proactive sort of methods, let there be proactive approaches and constructive methods they are needed to salvage the situation. I think I have finished the presentation. Thank you.
Thank you, Dr. Bhutyani, for your wonderful, insightful presentation. In the interest of time, we will not go into the questions. There are a few questions, but move on to the next speaker. And next speaker is our co-convener, Dr. Leslie Phil. Please welcome her here. And it's also my pleasure to introduce her. She is the founder and CEO of Arctic Ice Project, a nonprofit focused on restoring Arctic ice, adjunct lecturer at Stanford University, founder of Smalltech Consulting, inventor on 59 issued patents, authored numerous papers, spoken about our work at venues that include the United Nations, the World Economic Forum, in Davos, and the plenary speaker at the Arctic Circle Assembly. He has a master's and bachelor's degree in chemical engineering from MIT and PhD and master's degree in electrical engineering from the University of California, Berkeley. Please welcome Dr. Phil. Thank you, Dr. Phil.
Thank you so much. Are you seeing my screen? Have I succeeded in doing it? Perfect. It's going to. I can tell that we, especially if we're going to have some discussion, we need to, in the interest of time, get here. But it's in a weird mode. Let me adjust myself for another minute or so. Come on, get to presentation mode. I think I'm going to have to stop the share and try that again. Okay, we need not to do that. Sorry. There's a lot that you can't tell until you're actually showing it. Get there. There's presentation mode. Okay. Let's do this again. No, it's still in a weird thing. I apologize for this, especially when we're in a hurry. We don't need that. Okay. Well, I will say that it is a phenomenal privilege to be here, and that I will reopen my slides on my own screen to try to make this work. So let's get this again. And my apologies for the time delay. Particularly, I have heard loud and clear the pressure that's on us for reasonable and economical solutions, and certainly for making sure that we are doing the right things. They have to be practical, they have to be affordable. And let's try to get share screen up again. Goodness, I have not had this kind of trouble in a while, so it must be because I'm feeling the time pressure. My apologies. There's share screen. There's my slides. Let's share. Good. And let's see if I can get into that all-important presentation mode. And I don't seem to get Well, I guess we're just going to power on without it being officially in presentation mode. Is this nicely visible to you all? Can you see? Oh, there we go. Yay, we got what I intended. With all that fussing aside, I'm done, Phil. I'm okay. My husband has just sailed into the rescue. So apologies for all that kerfuffle. I'm here to present this solution that is quite hopeful. We've gone through a lot of work over a decade and have gotten ourselves to a technology readiness level of 3, which is how the US, NASA, such look at things, which means that we've gone through basic proofs of concept for everything. Basically, this is based on every degree matters, every degree is worth fighting for. We focus on sea ice. This is the thing that looked to be the most important lever in the world. And I so appreciated both His Excellency Grimsson's and Professor Wadhams' comments, especially on just how key ice is to the world. I'm not going to show you this video except to show you that these satellite images show you the beating heart of how we have relentlessly changed from having a rather large inventory of multi-year bright reflective ice in the Arctic oceans to about none over just the past few decades. And so that is what is driving a lot of climate change. I quote actually Professor Wadhams in a standard slide I show showing this great change over time, this enormous accelerating positive feedback loop change, as well as Professor Don Perovich. In Peter Wadhams's words, this is adding to the effect that we already are seeing, the global temperature rise, a factor of 25 to 50%, depending whether we're counting land and sea ice or just sea ice. And according to Don Perovich, summarizing these results, we've gone from 30% of Arctic sea ice cover being highly reflective to about 1% over just the last few decades from 1985. I will race through this as well because I do want time for discussion. And that is that ice restoration isn't just a matter of the technology. You really have to consider all the stakeholders, academic institutions, the people who actually live where you're proposing interventions. You need to collaborate, rather than say, hey, here's a good idea. Policymakers, the world's governments, how are we going to deploy it? How are we going to do it? And here is part of our crew, our principal engineer, Michael Thomas, part of UIC Science up in Utqiagvik, Alaska, far north as you can go in the US, so part of the native corporation there with UIC Science, and myself as we set up an instrumentation buoy. So we're one of the few climate restoration works that actually has gone into some field testing. And the reason we're allowed to do that is because this is a localized, you can test this on a localized and rather contained basis of a rather benign solution. So we're privileged in that. In short, what are we proposing? We're proposing, we've gone through a lot of materials testing, various approaches ranging from sheets to, well, all kinds of materials, natural materials, and have converged on over a decade of trying things out on something called hollow glass microspheres. And it's important to discuss that for a second because if you're adding a material to the environment, it better be a reasonable material. So here's what it looks like. It's basically a fine white powder that you may be able to see flowing here. Yeah. So it's like a fine white beach sand. The secret of why it appears to be safe in every test we've run so far, but there are more tests to run, is that it's mainly based upon silica. And silica is pretty ubiquitous in all of our world's ecosystems. You can see it in most of our rocks on Earth and in all the marine ecosystems as well. It comes in as sediment from rivers. It's, and that means that we've all evolved with it. And that helps. I've also wanted to choose something that would not bind with oil-based pollutants. If creatures in the oceans are going to eat these things, then you want to be able to make sure that it isn't carrying along poisons with that. And so that's the problem with plastics that is of such concern in the oceans. They they can be toxic on their own, but they also can bind with oil-based pollutants, and you're getting a lot of poison in at the base of the food chain. This is, you could think of this as a floating sand, really. And everything looks safe, but first do no harm is really the first principle that I'm insisting on that we have at Arctic Ice Project. We don't want to make things worse, for sure. So we're testing it, and we're very excited about upcoming collaboration with Sintef Oceans, who are expert marine biologists, to try to help answer not only is it as safe as everything that we have seen so far, including some outside testing, feeding it to a species of birds and a species of fish, but are there any unintended things? Could we change the phytoplankton, balance in some deleterious way if we did this? Would one be favored over the other? So those are the kinds of questions that we're asking ourselves. What does this have to do with ice melt in Himalayas or Greenland if we were to try to restore? Well, eventually these materials could find themselves in the ocean. So we have been focusing on sea ice as we think the biggest quick lever to try to help, by deploying in strategic areas, small areas of the Arctic, to have a leveraged impact to help slow global temperature rise. So we've started with sea ice. That's been our focus. So talking about glaciers, land-based glaciers, is an extension for us that we're eager to try. We have indications that it could work, but this is something that is a new thing that would require collaborations for our small team to be able to take on. On oceans, this really helps explain what we're doing. When you've lost sea ice, bright reflective multi-year sea ice, and you've gone to open ocean, on the order of 5% of the incoming sunlight is reflected. Most of it's absorbed. This is part of what's driving this positive feedback loop of ice albedo feedback effect in the Arctic. If you've got first year ice, you're reflecting more. So you're okay. You've begun reflecting more. But it isn't like what you used to have when you had thick multi-year ice with snow on it, which was highly reflective and which had a much greater presence in the Arctic until very recently. What our solution does is simply take this type of material, is our current best choice, unless we find a problem with it, in which case we'll find another material, test the heck out of it. But if we treat a relatively small area of ice, we can boost its reflectivity immediately. And in fact, we're kind of underestimating this. We have found some better materials this testing season. We've been continuing, even in the pandemic, to make a lot of progress. It's been a challenge, but it can be done. And so the secret here is you instantly boost this, and then over time, there are indications from the climate modeling that we would have, our dream, the potential to regrow the multi-year ice as well. Not just slow the melt, but start rebuilding. On a pond in Minnesota, staffed this season by our principal engineer, Alex Schultz, and volunteer homeowner and colleagues out there, we have found here is what this looks like, bare ice, pretty dark on this freshwater pond, snow, very, very bright. And as soon as we applied this season's hollow glass microspheres, an instant brightening of this very same area. So that's the technique. This could be useful on melt ponds, for instance. This could be useful on darkened glaciers, we believe. Here's a picture of us testing up in Utqiagvik with, again, a representative, Charles, from UIC Science, and our instrumentation volunteer of back then. And just, phenomenal to be able to work on, again, freshwater up there. And here's that homeowner pond in Minnesota. Here's what it looks like once we've deployed the material. Here's bare ice. So you can see an instant shift. This season, we were fortunate enough to move on to an even better material and get drone footage. This is what things look like after the melt. The untreated side, you always need a control and a test. The untreated side melted out before the treated side. And the treated side, the ice has gotten very thin here. The temperatures had gone up to 60 degrees Fahrenheit suddenly in Minnesota. Things are getting warmer. So things went quick. But the materials stayed in place through snow and rain events, and they will eventually drift off. Which is part of why you want to do rigorous safety testing. So we've seen that we can preserve albedo substantially. But of course, what do results on small areas on ponds, or as we move on glaciers, have to do with what you could do in the world? You just require climate modeling in order to get the job done. And we've been lucky enough to work with some colleagues at Climformatics with Arctic Ice Project, as President Grimsson said, our former President Grimsson, our new name, Arctic Ice Project, much improved. And we're nearing completion of a paper showing what can happen if you treated about 1% of the area of the Arctic at the Fram Strait, and it looks quite impactful. The Beaufort Gyre is up next for our modeling, which is that historic large inventory heat shield of Arctic ice in the past. People were asking about costs, so I thought I'd throw in this slide too. And so, we're talking about something like $10 million a year through 2025 to be able to complete all our evaluations on where are the most strategic areas, what's the safety really, what's the efficacy, how do we deploy it? And we're talking about something like, if we were to treat an area like the Fram Strait, of $1 to $5 billion a year to be able to actually deploy, which would need partnerships of people organizations who decided this was in the best interest of humanity, were very, very interested in helping to frame the right governance, et cetera, for these and policies for this. But this is against, billions of dollars of damages, just looking at a couple of events in the US alone. If you wanted a little more framework on that, we're talking about billions of dollars. And it's actually, I've seen things talking about this was just in 2018, billions of dollars by NOAA, our National Oceanic and Atmospheric Administration. If you talk about over the last couple decades, it's over $1 trillion of climate damages. Again, I think in just the US. So worldwide, it's just amazing the damages, and it's much better to invest in prevention. So every degree matters. Every degree is worth fighting for. Even if we miss the Paris Accord of 2 degrees C, limiting things to that, we still have to keep fighting, because every degree more, things get unimaginably worse. Climate refugees is part of it. It is just, we just can't go there. And so what we want to do here, when Sumitra Das, when Dr. Das approached me to talk about the Himalayas, we've been thinking that this could work on glaciers for quite some time, but we've been focused on sea ice. But it was like, this is the opportunity to really look seriously at the Himalayas and Greenland. I mean, the solutions are probably similar for what's needed, so that we could potentially slow drinking water loss for, as you've heard, 1 billion and more people, and reduce the rate of sea level rise, which is threatening to wipe out or vastly change many coastal communities, and some, nearly all of some countries, right? Not a good situation. So it's melting, right? The Himalayas are melting at an alarming rate. This we all agree on. I've loved hearing much more detail about this. And Greenland is melting at an alarming rate. But as you saw, things are getting darker. And so that means that something that we could brighten could be useful. Now, for sea ice, we're thinking about deploying from ships. On areas like this, I think the deployment and the acre by acre battle, or square kilometer by square kilometer battle, could be rather ferocious. And so while we think we can make things brighter, what the economics will be for that, I don't know. As you saw, for sea ice, we're thinking $1 to $5 billion a year for an area of about the size of the Fram Strait. Here, Greenland's ice sheet is, I think, 17 times bigger than what we were modeling there. And the Himalayas is, I think, greater still. But could glacial ice darkening be reversed by modifying these surfaces, right? And not just the ice, but these materials by design are floating. And so if we put these on surface water, will this help slow the melt? And the answer is we think there's a real potential there, but we haven't been able to prioritize that work yet, because we are a small team, working flat out on sea ice. If this were to come to pass, and should we get in more funding and collaborations, we could take this on, and this would be part of what I'm very excited about. But I want not to be blind to other options, and I'm glad to see that other people were discussing these a lot. These ice stupas fascinate me as well. Sonam Wangchuk, I've spoken about him in my Stanford class on climate solutions that I teach every fall, and have hoped to get him to speak in person about this, but I know he lives very remotely. But this is such a great concept to harness the pressure head of melting water and turn it into snow again in the right temperatures to build up a shape of the ice that's going to melt slower. They use this for agriculture there. And I just think that's got some potential to slow things in some places. And of course, marine cloud brightening, glacier grounding, glacier protection underneath the sills are things that people talk about that really should be assessed altogether of what approaches make sense. Restoring ice certainly can be a crucial lever on slowing climate change impacts. What we've seen in Arctic Ice Project, looking at the sea ice interventions, we're looking at our NASA retirees who are on our board and who volunteer with us are estimating a 15 years more that we could get from doing the kinds of interventions that we're talking about in the areas of sea ice we're talking about. So this is a crucial lever to slow these impacts, and the collaboration and funding are what are required to get the job done in time, and an open-mindedness of how can we do this. And I have learned that we really need to work with the people who live there and have these local based solutions. I love the cool roofs there that you were describing, for instance. These sorts of insights are absolutely critical to actually solve the problem that needs to be solved and make sure that these things are to the benefit of humanity and to the world's ecosystems. And so I'll change what I've generally been saying about saving Arctic sea ice to every degree matters, and polar ice is critical to slow the devastation and to buy time. And I think I've left us about 10 minutes for our discussion. So thank you very much for your attention, and thanks for letting me race through that.
Leslie, thank you so much. It's a wonderful thought. And we learned a lot. Perhaps we can use your solution to save the Arctic and the Himalayas as well. So thank you very much for educating us with the solution. I wanted to, we have very little time left, only 10 minutes, and we have a lot of things we plan to cover. One of the things was to discuss the planning for this next symposium, next steps. So we have 10 minutes. Originally, we thought about having this symposium, something like July or something, July, August, September. Wanted to get, with all your permission, to get fix a date about this time, what date or time we should be trying to host that symposium. That's one thing I wanted to achieve. The idea was to get all the solutions, not only create the awareness of the problem, but also to get the collection of solutions that can solve this problem, like marine cloud brightening. And I'm speaking with Steven Salter about that, or like Sonam Wangchu's solution. We can all talk about this in this, and then ultimately create a task force from this and to do the testing or whatever that is necessary to go forward. So ultimately, that will be a progressive series of talks and coaxing people to get to the point we want to get. With that, I want to see from all of you who are present, what would be the next step, and maybe the dates for our next symposium. His Excellency, do you have any comments on that? You had a plan to host the similar symposium in UAE. Do you have any plan? You can share that plan with us.
We don't have that at the moment. We have a formal agreement with the government of the United Arab Emirates, but until the world is in a different shape, the pandemic no longer dominates how people decide on travel or not. We will not be able to set the date. But quite frankly, I think that's not the issue. The issue is to get an agreement from the new government of Greenland and one of the Himalayan governments to decide on an area where this real-time experiment can take place. And then to seek funding, if that's not yet available, for that experiment. When I talk about this project to other people, the greatest difficulty is to try to explain to people that you don't need to spread this material all over the Arctic in order to achieve success. Because people have a conceptual difficulty in understanding that even in a relatively small area, it can have a big effect. So I think we have three challenges now, and I think we should concentrate on those rather than planning for another symposium. Because as I understand it, but admittedly, I am not the key scientist, but as I understand it, the science is already in the state that there is no need for further research so far as the real experiment is concerned.
So let me
Sorry?
respond to that because I'm very excited by the thought that there could be, the right area and the right funding and the right permissions to get going on that. We are technology level 3 means we're only at proof of concept. There are a lot of questions still to answer, but answering some of them in localized areas on
I
Greenland.
cannot hear what you're saying. Maybe it's the fault of the internet of my end.
Oh dear. Shall I try again? Can you hear me now?
Yes.
Oh, great. Yes, I'm very excited as you speak about the possibilities of finding the right spots in Greenland to get permissions and to be able to try something. I don't want to overstate how ready we are. We have worked on, ice and snow on freshwater lakes and ponds, and it's looking very promising. But this would be really exciting if we had the right permissions and the right funding to do it. Our current team, without those added ingredients, not sure we can take it on. And technology readiness level 3 means that had proof of concept, but there's a long way to go. But this could be part of that. That would be exciting
No, but
indeed.
actually, I mean, in practical terms, I think you need to have funding decided and agreed on to do this experiment, because I don't want to go to the new government of Greenland and let them spend the administrative bureaucratic time. And it's a small country with a lot of tasks. If then the funding is not available, because it's not realistic to expect the government of Greenland to take a decision and take it through the governmental system to give you a permission to do the experiment on some territory that belongs to Greenland, if then the funding is not available. I'm not going to let them, to some extent, waste their time, if that is the case. So the first order of business is to get the funding for the experiment, on the premise that Greenland and the Himalayan, perhaps an Himalayan country, will agree to it. Let's say you've got that. Then I think in a reasonably short time, we could get the government of Greenland to agree to give an ice march to do the experiment. And then thirdly, after that, we can go to a Himalayan country and say, okay, Greenland has agreed to do this, will you agree to do it as well? Even if the Himalayan country doesn't say yes, it's worth doing experiment in Greenland. But I'm reasonably confident that either India or China or even Bhutan would agree to do this experiment in some kind of ice march. So I firmly believe that now we have reached the avenue of these practical steps, and that is okay. You can continue the science. I have nothing against that. If this project is going to be a part of the global decision making in the next 3 or 4 years about how to deal with the global threat of climate change, this is what we need to do. And then have a 1-minute answer why it is enough to do in a relatively small area in order to get sort of big global impact.
Agreed. But the funding has been the issue. This is we are a nonprofit. We're still completely dependent on philanthropy until governments start stepping up and deciding to direct some funds to this kind of work. And it's been controversial, especially.
I lost you, whether it was my fault.
What? I'm sorry.
What you said before, you froze on my screen, so I didn't hear what you were saying.
Okay, yes. And you froze for a second too. I was saying, yes, the dilemma there is the funding. We're still a nonprofit completely dependent on philanthropy. And until governments, I think, or local concerned areas step up and start helping in areas like this, it's a long, slow road. And I think there's hope, in our country that things have changed substantially and we may get there. But any voices that anybody in this discussion are able to lend to help find that kind of funding, that would be phenomenal. Of course, we don't start out needing
No,
a
but
billion.
let's be honest about it. I mean, if President Biden and John Kerry are serious about what they're saying,
Yes.
it should be no brainer for the US to provide $1, $2, $3, $4 million in order to do this practical experience in either Greenland or the Himalayan regions or both. So for the funding community in the United States, even the official bodies, this is a kind of test case. Are they serious or not? They are talking about trillions of dollars to achieve their aim. And I know both of them. I mean, they are open to practical suggestions because that's what everybody is now looking at. And if something can buy us more time, it's definitely a monumental issue. And what you're asking for is actually peanuts in the scale of what they are talking about. So be ambitious, approach these guys and just tell them, I mean, now you have to deliver.
May I ask you a giant favor, please? And that is, could you write a letter, an email of introduction saying how important it would be for us to have a meeting with them for this purpose? Just saying pretty much what you've been saying here. Would that be possible? I know I'm being pushy, but you need to be in this situation, I think.
Well, this is a matter for the US to decide. I mean, the science comes out of the United States. This is a matter for the United States. Of course, if the United States fails to provide the funding, we could go to some other resources. But the first order of business is for the US to decide whether a monumental US scientific contribution to this campaign is going to be funded in this way for a few $1 million in the next 12 to 24 months. And you need to get to either Kamala Harris or John Kerry or his staff and others or some key senators. It's not a question of writing emails or writing letters. I mean, you have to present this to them sort of face-to-face or some of their key officials sort of face-to-face.
Well, it's trying to get that audience granted that I think could be the trick. So, yes, great. Well, we can continue that discussion. But thank you so much. Yeah, I'll stop taking up time here for that. But that's really important. And thank you so much.
Thank you, Leslie. Thank you, His Excellency, for this discussion. And particularly, I'm very delighted to see His Excellency's support and commitment of this project. That is what we need at this time. Need your support. We'll reconvene among the co-conveners and figure out the next steps, and we'll inform you, His Excellency, and everyone in this panel and the audience what would be our next steps. And with that note, I know I'm running out of time. I'm very mindful of the time. Don't want to pass. So I'll give it to Mr. Rituraj Fukan, who is a co-convener for this webinar, to say a few words, give a vote of thanks. Thank you. Thank you, everyone, for attending. Thank you, all the panel.
Thank you, everyone, for a very engaging conference. The discussions were really wonderful. And first of all, I'd like to thank His Excellency President Grimsson, of course, for taking the time to set the context of this conference and also participate in the discussion that followed. Sir David King, thank you for your time. I think he might have left. I saw a message there. And thank you for bringing in that methane context into it and showing those wonderful, those thought-provoking images from the Russian Arctic. Thank you, Dr. Peter Wadhams. We were actually co-panelists on Earth Day 2018, I guess, during the launch of the We Don't Have Time No-Fly Climate Conference, if you remember. And thank you very much for your presentation. Thank you, Dr. Mahendra Bhutyani, for presenting about the scientific developments and the solutions from the Himalayan glaciers at such short notice, and despite the technological challenges that we faced. Of course, our co-convener, Dr. Leslie Field, for her presentation and the big solution that we are looking at. We want to take forward all of us together in this. I would also like to call out Lieutenant General Arun Kumar Sahni, a former commander of the Indian Army who was present here. He is one of the key figures from the Club of Rome in India, a think tank. Maybe he's one of the persons who can help us take this forward with the government of India, along with Dr. Bhutyani. A big shout out to all the Climate Reality Project, Climate Reality leaders and the organizations for collaborating. All the participants from Arctic Ice Project, the Healthy Climate Initiative, especially especially Mr. Ghosal and Mr. Chandan Bhattacharjee, who have worked behind the scenes for making this a success. The interns, Arna Banerjee and Ash Mukherjee, for their background work, and of course to all the participants who have been keeping up the chat and the Q&As active. Thank you all very much, and hope to see you all soon.
And may I make a
Thank you
final?
very much. Thank you.
I'd like to make a final thank you to everyone, and
Absolutely.
I'm sorry if I overstepped Chairman Grimsson, but it's really exciting to see this work. It's really, I feel my toes are to the fire to get this job done, and it's incredibly important. And I'm incredibly honored that you asked me, Dr. Das, to be in on this, and it was incredibly inspiring to hear from every one of you about just the really important perspectives on what needs to be done, how urgently it needs to be done. I just am deeply appreciative of being here. Thank you so much to you all.
Thank you.
Thank you.
Thank you. Thank you.